Hello to all. We are group number 11 and our project is cat versus dog classification using CNN. So here we have imported the all important libraries like we have imported the pandas to read our file. We have imported numpy to convert our file in array. We have imported matplotlib.pyplot to plot the graphs, and we have imported the Seaborn libraries to plot the various graphs. Then we have imported the warnings to avoid the warning, and we have imported CV2 to read the images. Then we have loaded the data set. Here the training data set and test data set. Then we have displayed the xtrain here. And then we have displayed the length of xtrain. Then here the length of xtest. Then length of train. Here, here we have read the test test file to display the data. Then we have displayed X train, and then we have displayed Y train. Here we have plotted the conv plot to show the level of dog and cat. Then we have displayed the X test. Here we have displayed the Y test. Here 0 represents the cat and 1 represents the dog. Then we have displayed the conv plot for Y test. Here we have displayed the first picture of X train. Then we have displayed the here X train, and here we have displayed the shape of X train. Here we have done the reshaping of X train and X test. Then we have displayed the X train here. Here we have done the reshaping of Y train and Y test. Then we have displayed the shape of Y train. Here we have plot the X train. Here we have used random module to use any random picture. And then we have displayed the X train here. Here is our model building. So the model that we will be using is sequential. Sequential is the easiest way to build a model in keras. It allows you to build a model layer by layer. We use the add function to add layers to our model. Our first two layers are convolutions 2D layers. These are convolution layer that will deal with our input images, which are seen as two-dimensional matrix. So we have used 32 and 32 in the first and second layer are the number of nodes in each layer. This number can be adjusted to be higher or lower depending on the size of the data set. In our case, we are using 32 and 32. So we will stick it for this for now. So kernel size is the size of the filter matrix for our convolution. So a kernel size of 3 means we will have 3:3 filter matrix. Here we are used 3:3 kernel size. So activation is the activation function for the layer. The activation function we will be using for our first two layers is the ReLU, or rectified linear activation. This activation function has been proven to work well in neural networks. In between the convolution 2D layer and the dense layer, there is a flatten layer. Flatten serves as a connection between the convolution and dense layers. Dense is the layer type we will use for our output layer. Dense is a standard layer type that is used in many cases for neural networks. We will have 64 nodes in our output layer, one for each possible outcome. The activation we are using is sigmoid. So now we are here for compiling the model. Next, we need to compile our model. Compiling the model takes three parameters: optimizer, loss, and metrics. The optimizer controls the learning rate. We will be using Adam as our optimizer. Adam is generally a good optimizer to use for many cases. The Adam optimizer adjusts the learning rate throughout training. The learning rate actually determines how fast the optimal weights for the model are calculated. A smaller learning rate may lead to our more accurate weights up to a certain point, but the time it takes to compute the weights will be longer. We will use categorical cross entropy for our loss function. This is the most common choices for classification. A lower score indicates that the model is performing better. To make things even easier to interrupt, we will use the accuracy metrics to see the accuracy score on the validation set when we train the model. Now we are fitting our data into model. Now we will train our model. To train, we will use the fit function on our model with the following parameters: x train and y train, and the batch size and the number of epochs. For our validation data, we will use the test set provided to us in our data set. So the number of epochs is the number of time the model will cycle through the data. The more epochs we run, the more the model will improve up to a certain point. After that point, the model will stop improving during each epoch. For our model, we will set the number of epochs. Here is 5.
Hello.
So here we can see our accuracy is 95%. So now we have used our data X test and Y test to evaluate our model. Now by using random function, we have called random picture from our data set to evaluate the model. Now as you see here, it's showing, it is the picture of cat and it's showing the cat. Thank you.